radicals, and it does say part 1, so we're only going to do a little bit of it, just enough to get you acquainted with it so you're not completely unaware when you go into geometry, because in geometry you do a lot of radicals. Okay, so one of the rules with radicals, as we've talked about, is like if I have the letter a times b multiplied together, you can actually write it as the multiplication of the radical a and b. So kind of with division, if you have a divided by b, it's actually the same thing as radical a divided by radical b. And they can go either way. So you can combine or you can separate. So that's kind of what we're doing here. So it says break apart the radicands, and that's just the numbers on the inside, using the quotient rule, and that's this right here. So we're going to have radical 49 over radical 100. Well, we know the square root of 49 is 7, and the square root of 100 is 10, and voila, we're done. Now, those are perfect squares, so that makes it a little bit easier, and that's basically what happened right here. Look for perfect square radicals and simplify them. And if that's not the case, then you have to go to step 3. So we're going to break this up as a square root of 8 and the square root of 32. Well, those are both not perfect squares. So we have to simplify or divide the radicands. And you can either go to this step and simplify, or you can simplify and then separate. So I'm going to kind of show you 2 different routes. You can go this way or you can go this way. Okay, so if you separate, you can do it that way, and you're still allowed to simplify the 8 and the 32. So 8 and 32, actually I should say this differently. You can't just, yeah, you can, never mind. 8 and 32 are both even, so if you take this and divide it by 2, you get 4. And if you divide this by 2, you get 16. Now, the reason you're allowed to do that is if you do it within here, you would have had the square root of 4 over 16, and we can simplify more. And then you could split them up to look like this. Now, we can simplify more, or we can keep it as is. The square root of 4 is 2, the square root of 16 is 4, and if we simplify that, it's 1/2. If you go this route, you could say, okay, 4 and 16, that's the square root of 1/4, the square root of 1 is 1, the square root of 4 is 2, and voila, it's 1/2. So, different ways to go about it. Okay. I'm going to skip 4, and because it's just not needed. 3 and 16, the question is, can that simplify? So that should be your first question. I think that'd be a better way to think of it. And 16 is not divisible by 3, so we're going to separate. So square root of 3, square root of 16. We know the square root of 16 is 4, so you have the square root of 3 over 4, and that is allowed. Okay, you're just not allowed to have radicals on the bottom, and we'll talk about that. And by talk about that, I mean look at number 5. Okay, so 7's kind of on its own, so we can look at 108 and 6 and say, does that simplify? Well, 108 divided by 6 is 18. The question is, where does it go? Well, if you had 108 divided by 6, it'd be 18 over 1, which is just 18. So you really have 7 square root of 18. And then you have to ask, can you simplify 18? Well, 18 is divisible by 2, so that gives you 9. And then that's divisible by 3. So the 3 comes out and multiplied to the 7, giving you 21 square root of 2. Okay. Now, what if you have a coefficient in front of both radicals? You can actually ask yourself, can you simplify this? And you can't, so then you ask yourself, can you simplify this? And you can't. So we just see what we can do. And that actually leads us to the next question. So we're going to stop there because it's going to have to be rationalized. So number 6 leads us into the next section. So I'll see you in the next video.